Hey math kids, we're going to continue this lesson and talk about technology. And so we are given, let's see, it says variable x is normally distributed with a mean equal to 40 and a standard deviation equal to 10. So what we're going to do, we're going to bring in a calculator. We're going to find the normal CDF function. So I always just go to the catalog and then type in an n. And then we see normal CDF. Okay, and when we're plugging this in, we want to plug in the value that we're looking at first, like the lower value, then the upper value, and then we plug in the mean and then the standard deviation. And so the first problem, they want us to find the probability that if we randomly selected someone, they would be between 37 and 48. And so if we go back to that calculator, what we're going to do is we're going to plug in our lower bound, which is 37. Then we're going to plug in our upper bound, which is 48. And then we plug in our mean, which is 40. And we plug in the standard deviation, which is 10. Just hit enter. And so we have a 40, or like our probability is 0.406, or about 41%. And so this is 0.406. Okay, the next one we're doing, we want x to be greater than 45. So we go back, and I'm going to do a trick. I'm going to go second entry, and that's going to put in what we just had. And I'm just going to delete everything, I guess. Maybe this isn't faster. I don't know. Okay, so when we're greater than 45, our lower bound is going to be 45. And then we just want to put in a really big number. So I just do a bunch of 9s. Okay, that's like infinity, in a practical sense, that's infinity. And then we just plug in our mean and our standard deviation. And we get 0.309. Or roughly 31% chance. Okay, now we have probability x is less than 26. So we go back to that. Here, I'll go through the process again. So catalog, hit n, normal CDF. Okay, this time our lower bound is a really small number. So I'm going to say negative, and a bunch of 9s. Our upper bound this time is 26. And then we just do our mean and standard deviation. We get 0.081. Okay. Just to kind of describe what was going on right here. Essentially, we had our normal curve. We had 40, and we wanted to know between 37 and 48. So it's like here and here. Here's 37, here's 48. We essentially wanted, if we thought of the entire area as 1, that area is going to be 0.406. For this one, once again, we're at 40, but then we check at 45. And so the area right there, once again, if the entire area is 1, the area of that piece is 0.309. And then, whoops, do that, that's 40. And then if we go down here to 26, and everything below that, that little sliver, that would be the area under the curve in that situation. Okay. New problem. The times taken by students to complete a puzzle are normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6. Okay, calculate the probability that, so there's two parts, a randomly selected student took at least 30 minutes. So basically x is greater than 30, greater than or equal to, but actually when we do this, that doesn't matter. Okay? So we're going to go through the same process. We're going to say second catalog, hit the N, go to normal CDF. Our lower bound is 30. Our upper bound is infinity, or a bunch of nines. And then our mean is 28.3. And our standard deviation is 3.6. Hit enter and we get 0.318. And that's all you have to do, 0.318. So it's about 32% chance that if we randomly selected a student, they would take longer than 30 minutes or longer. Okay, so out of 10 randomly, out of 10 randomly selected students, so we have 10 students, random, 5 or fewer, we're going to say y less than or equal to 5. Took at least 30 minutes to complete the puzzle. Okay. All right. So when we have like a specific number and we're trying to figure out how many of that specific sample we took, we now change to a binomial distribution. And so when we look at the binomial distribution, it looks like this, where it's n, comma, the probability. And so what we need to do is go back here, and we're going to find the binomial CDF. So we hit a B, binomial CDF. Okay. And number of trials, so we had 10 trials. And then I'm going to input my answer. I'm going to say second answer, because our probability is just that answer that was right above. Okay. And let's see. It didn't like that answer. What happened? Oh, I forgot to tell it how many to pick. Sorry. Let me do that again. Okay. So I'm going to go second catalog, binomial. So binomial CDF. There were 10 things, like 10 students that we chose at random. And then the probability of getting a success was 0.318. And then we need to tell it how many we choose, or how many we chose. So we chose 5. And that gave us 0.938. Okay, so I just want to mention a couple things. So CDF, like if it's binomial, normal, whatever, CDF refers to when we're looking at like a range of values. Okay, and so that's why we've been using CDF. And then binomial is when we have a set number of participants that we choose from, and then we want to know like 5 or less, or 5 or more, or something like that. Do something. And once again, if it's like a range of values, like less than or greater than, then we use CDF. PDF is when we're looking at a specific place. We're looking at one value. If this said y equals 5, we would use a PDF instead. Okay, if you need additional help, please come to Math Lab. Until then, calculator.